quadrilateral is a kite. Here are examples of a kite. There are no sides that are parallel. However, there are sides that are congruent. Now, by definition, a kite is a quadrilateral with two pairs of consecutive congruent sides, and each pair is different. These angles are called vertex angles, and the other pair is called the non-vertex angles. Now, let us discover some properties about the angles. I have my kite, and these are the two congruent sides, and this is the other pair. Let's take a look at the two vertex angles. Looking at angle E and angle L, do they look congruent? It's rather quite obvious that those two vertex angles are not congruent. Now let's take a look at another kite. I have angle O and angle E as a pair of vertex angles. Do they look congruent? It's rather obvious that angle O and angle E are not congruent. Let's take a look at the non-vertex angles. Angle C and angle R. It seems congruent. Let's check. I will copy angle C and I will compare it with the other angle, angle R. These are two non-vertex angles. Let's try it with the other one. I will copy angle U and compare it with angle B. Now that you have observed two kites, what can you say about the non-vertex angles of a kite? Complete this statement. Let us draw the diagonal connecting the vertices of the two non-vertex angles. That's from point B to point U. What do you think about that diagonal? Does it bisect the non-vertex angles? Let's check. Now let's compare. Definitely, the diagonal does not bisect any of those angles. Let us look at the other diagonal connecting the two vertex angles, and that means we're going to draw the diagonal EL. Does the diagonal EL bisect the vertex angles? Let's check. I think it's very clear to us that that diagonal bisects the vertex angle. Let's try the one at the bottom. And it's very clear to us that the diagonal connecting the two vertex angles bisects the two angles. Is it true for the other kite? Let's try this one. I will copy one angle. And compare it. Now we're getting into something. Let's try one more with this angle. Now that is very clear. And this is another property of a kite that is involving the diagonals connecting the two vertex angles. It's your turn to complete this statement. Let us have the two diagonals of the kite. I will draw the second diagonal, diagonal CR. It seems very obvious how the two diagonals intersect. They intersect at point Q. I will use the corner of a piece of paper and show you how they intersect. I'll do this again on another kite. Now, as you think of the next property of a kite, fill up the statement. But there is something a bit more to discover. Let's look at the point of intersection. It seems obvious that OQ and QE are of different lengths. But how about CQ and QR? This is the diagonal connecting the two non-vertex angles. Let's try and test what CQ does and compare it with QR. Let's take a look at the other kite. This is the point of intersection. We know that EQ is definitely shorter than QL. But let's take a look at QU. And compare it with QB. Again, this is the diagonal connecting the two non-vertex angles. What does the other diagonal do to this diagonal? I will repeat. What does this diagonal EL connecting the two vertex angle do to the other diagonal connecting the two non-vertex angles? Now it's your turn to complete this statement. This completes our series of discoveries on the different quadrilaterals. Summarize them on your notebook when you meet your teacher the following day.